In this video we're going to look at vector notation, that is different ways that we can write about a vector or call a vector. Remember, a vector is a quantity with both direction and magnitude. Now, the simplest way to talk of a vector, and the way that gives us the most information, is to use a line segment to represent that vector. So we might use a line like this. It has a certain length, which is the magnitude, and we put an arrow on it to show that it has a direction. Often we will label the ends of that line with 2 letters, and we might want to be able to refer to that line at a later stage. And there are 2 ways we could do that. We could refer to it in the first way is writing the 2 endpoints of the line, A, B, but to show that it is a vector, to show that it has a direction, we put an arrow over the top of it. So AB with an arrow over the top of it refers to that line segment, that vector. The other way is to label the line with a lowercase letter, such as A. If it is typed, that A will be in bold. If it's handwritten, we can't handwrite in bold, so we underline, usually with a squiggly little underline, to show that it is a vector, not just a line. So in this case, AB, the vector A to B, we have called it the vector A, little a. That's just a way to refer to the vector. We can also look at the vector going backwards from B to A. So the vector from B to A going in the opposite direction would be if our arrow was pointing the other way, and that is equal to negative A. So if it's going in the opposite direction, it is negative A. The final way we can look at vectors is using a column vector, or the component form of a vector. And the column vector we will have seen before in translations. So a column vector looks like a pair of brackets, like this, big brackets, with 2 numbers, one on top of the other, something like 3, 4. And what that means is the top number is the number we go across, and the bottom number is the number we go up or down. So if we were to start at one point, we would have to go across 1, 2, 3. We would have to go up 1, 2, 3, 4. So the vector represented by the column vector 3, 4 would be that vector there, AB. The direction is important. Remember, if it had been the other way, if it had been -3, 4, we would have had to have gone 3 to the left and then 4 up. If it had been 3 minus 4, it would have been 3 to the right and 4 down. And if it had been -3 minus 4, then it would have been 3 to the left and 4 down. All of those column vectors would have had the same magnitude, but they would have had different directions. So it's important that you go in the right directions. This would be left and up, this one would be right and down, this one would be left and down, and our original one is right and up. We could then refer to this vector later on as AB with an arrow over it, and we could say AB is equal to 3, 4 in column vector form or component form, and that would tell us what AB is. So 2 vectors are equal if they have the same magnitude and the same direction. So if we have our 2 if we had two vectors, if they were going in the same direction and they were the same length, then they would be equal. We call this one A and this one B, then A is equal to B in this case. If they are parallel and have the same length, that means they are equal vectors. The opposite is if they are negative of each other's. So one vector is the negative of another if it is in the opposite direction but has the same magnitude. So they are parallel, have the same length, but the arrow is in the opposite direction. For example, if we had A, B, call that one A, and we had a parallel line, the same length but in the opposite direction, which was C, D, that one would be negative A, because it's in the opposite direction, even though the line segment is the same. So let's have a look at a question and how we might use this notation. Here we have a parallelogram, A, B, C, D, and we are given that A, B is equal to A, and B, C is equal to B. Now we might be asked to find various other things in terms of A and B. For example, we might be asked to find BA. Now BA is the same length as AB, it's parallel but in the opposite direction, so that one is minus A. We might be asked to find CB. Similarly, that is the same as BC but the opposite way round, same length but opposite direction, so that one is minus B. We might also be asked to find AD. Now that vector has no letter associated with it. AD has no letter that we can call it. However, as this is a parallelogram, AD is parallel to BC, and it's also the same length as BC. So AD is equal to the vector BC, which is the vector B. Finally, we might be asked for CD, the vector CD. Again, there is no letter, but as it's a parallelogram, CD is parallel to AB, but in the opposite direction. So CD is equal to minus A, because it's parallel to AB, has the same magnitude, but the arrow CD is in the opposite direction to AB. So that's a brief introduction to vector notation, the different ways we can see it. We could have two letters with an arrow above them, a lowercase letter with a squiggly line underneath it, or a bold letter if it's typed. That would be how it would be typed. It would be bold, not with a squiggly line underneath it. And column vector notation, or component form, which tells you how many you need to go across and how many you need to go up. The important thing to remember are equal vectors are if they have the same direction and the same magnitude. Negative vectors have the same magnitude but are in opposite directions.